acceleration at steady speed. Now, if we look at the centripetal force and acceleration, we know that centripetal force and acceleration are at right angle to the object's velocity, right? And using
Yes.
this, we can explain that why speed is remaining constant, right? See, if we say ki, we know that if speed is changing, this can be done by application of force, right? So if force is to make the change in object's velocity, the change in object's velocity, it must have component in the direction of object's velocity. Only then it can bring a change. Example, let's say this is an object. It is moving on the ground in this direction, right? Horizontally, it is moving. If you apply any force like this in this direction or maybe vertically upward, do you think it will change the object speed?
No, sir.
No. Why? Because it is acting at right angle to this. But if you apply force in this direction, do you think now it will affect the object's velocity?
Yes, sir.
It will affect the object's velocity. Why? Because we have done resolution of vector. If this is applied, so we can resolve it into two components. One will be this horizontal, another will be vertical. So this vertical component will have no effect on the object's motion, but this horizontal component will have, right? So
Yes.
if a force is to make the change in object's velocity, it must have component in the direction of object's velocity, right? But when we consider the circular motion, our force is already acting at 90 degree to the velocity, right? Means they are component in the direction of, if we have to find, like, how do we find components? Like, if I ask you, this is F, it is acting at an angle theta. So what will be this component? This component will be F cos theta,
Yes, sir.
right? But if we say that theta is 90 degree, force is acting at 90 degree. So what will be the component? F cos 90 degree. And we know
Yes, sir.
that cos 90 degree equals 0. So this will be 0,
Sir.
right? So this means K force when acting at 90 degree, it has no component in the required direction, right? So force is acting on the object without making any change in the speed, means it will not increase or it will not decrease the speed, right?
Yes, sir.
Secondly, we can use the idea of work done also to explain this idea of work done. How can we use idea of work done? See, we know that when object moving in a circle, its speed remains same, right? And work done is defined as force into distance, and distance in the direction of the force, right? Now, distance moved by object in the direction of centripetal force. If I consider this circular path, centripetal force is acting toward the center. Is object moving any distance along the radius?
No, sir.
Object is moving along the circumference only. Therefore, work
Yes, sir.
done is 0.
Yes.
And if work done is 0, we know that whatever work is done, that will be uh, producing change in the kinetic energy, right? If work done is
Yes, sir.
0, this means change in kinetic energy will be 0. Change in kinetic energy will be 0. This means speed remains constant,
Yes.
right? Now, there is question number 12 in your book. Now, if we discuss in more detail circular motion, right? Uh, if we consider this as our Earth, and let's say ki on the surface, we are projecting any particle, right? let's say there is a large cannon and on the surface, and it is capable of firing horizontally, right? So what will happen if it is fired too slow? Let's say this is a cannon, and from this cannon, the uh, if object is fired very slowly, what will happen? It will cover a small distance and it will fall on the surface of Earth.
Yes, sir.
If we will increase the speed, what will happen? It will cover a large distance.
Yes.
Do you think at a certain point, if you will fire, it will not fall on the surface of the Earth?
Yeah.
What will happen to this? It will keep orbiting the surface of Earth.
Yes.
But if you will fire it too fast, it will leave the surface, right? Means if it is fired too slowly, gravity will pull it toward the ground and it will land at some distance, right? As the initial speed is increasing, object is landing further from the cannon, right? So at a particular
Yes.
speed, if we will fire, so at that particular speed, the object will always be pulled by the earth, right? And it will keep on orbiting the earth, but it will never fall uh, on the surface of the earth. It will keep on orbiting. But if you will fire it too fast, it will travel off into this space.
Sir, so when there is at a particular speed, the centripetal force acts, right, at that
Uh,
particular speed.
because there
But
is
if it's more than that, then it
it won't and it will not undergo the circular motion.
won't be affected.
Uh, Fine.
Yes.
Now we will see how can we calculate the centripetal acceleration and centripetal force. Calculating centripetal acceleration and force. We can consider example of circular motion. I will consider this. Let's say this is the path of the circular motion, right? And this is the, let's say this is center. Initially, the object is at position A. After some time, object reached position B, right? And when object reached position B, it has covered an angle of delta theta, and this is R. And if this is R, so this will also be R, right?
Yes, sir.
And velocity, if I draw velocity at these points, so from this point, this will be the velocity, let's say VA, and from this point, this will be the velocity, let's say this is VB. This is VA and this is V. Here we are considering any example, consider spin, we are spinning a bung around the circle or any other, right? If before driving this expression, if I ask you, what factors do you think that the force that is required to keep, let's say you are, there is a stone, right? This stone is tied to this string of length L and mass of this stone is M, right? So when it will be revolving in a circle, a centripetal force will be there. So what factors do you think the centripetal force will depend on?
Um, the radius,
Radius means the length of the string,
length of the string. Yep.
or you can say the radius of circular path. Any other factor do you think?
Um,
Mass
mass, yeah, mass.
and the speed with which you are revolving.
Yes.
Now, how does this affect? Like if radius is more, what about the force required will be less or more? What do you think?
If it's more, that means more force is required.
But practically it will be less. Now
Okay.
just imagine
Hmm.
uh, the mass is m, same mass, You have tied with a very small string. If the string is very small, you will experience more force. It will be quite difficult, right? If the string is very large, centripetal force required will be less. This you can try at home also, right?
Oh, that's
So
why it's like difficult to, when it's small, it's difficult to get it into circular
circular
path.
motion, yeah,
Yeah.
right? So more the radius, less force will be required, right? And mass and speed, if more the mass of the stone, more force will be required. And if you want to rotate it with more speed, again, more force will be required. These are the factors. Now we will derive this relation, right? Now in this expression, if I have to find, let's say कि when object reach from A to B, right? Object takes time, delta t time objects take. In delta t time, object reach from A to B, right? Okay. If you remember, we have defined angle in radians, right? Angle in radians, how do we uh, define that? Theta means angle in radians
Yes, sir.
is equal length of arc
By radius.
by radius. This is what we do, right?
Yes.
Now, if I draw this vector triangle here, this is VA, this is VB, and let me correct. See, since we are considering, we are saying that the magnitude speed will not change, magnitude will not change, and in vector magnitude is represented by length. So we will keep the length same. This will be VA, this will be VB, and this will be the change, that is delta V. Right? Now, if we consider this side and this side is same, and right. So if I consider a small triangle here, if I consider a triangle like this, let me join this. If I join A and B, right? So this angle and this angle will be equal,
Yes, sir.
right? Now I have drawn this VA and VB here, right? Since V and VB have same magnitude, so these two lengths will be equal,
So
right?
VA and VB.
VB.
Yeah. Yeah.
And
Yeah.
there
Yes,
is
sir.
a property, whatever angle is in between the two lines, their perpendiculars will also have same angle. This is a mathematics property. Now, angle between these two lines, OA and OB, OA and OB is delta theta, and
Yes, sir.
this line and this line are perpendicular, so they will also have angle delta theta. Is it fine?
Between each other.
If let's say these are two lines, right? If they
Yes, sir.
two line have angle theta, so if you will draw perpendicular of these lines, they will also have angle theta. This is a property in maths.
But sir, you said for, since UA and UB are perpendicular, they'll have the same angle.
Means
But is it in between both of them? Because in the vector diagram, it's between both of them, right?
see, OA and OB have angle delta theta.
Yes, sir.
So their perpendiculars will also have angle delta theta, and their perpendiculars are
Okay,
VA and
together,
VB. So they will
together,
also have
right?
angle delta theta.
Okay, sir.
Now, since these two sides are equal, so these two angles will also be equal.
Yes, sir.
So can we say, let's say, let name it as OPQR. Can we say triangle OAB, right? And instead of OAB, better if we say uh, triangle AOB. triangle AOB is similar to triangle PRQ. Can we say this? Similarity you
Yes,
have
sir.
done if all three angles are
Yeah.
equal to it is same, right? Okay. Now, if triangles are similar, then the ratio of their corresponding sides is also equal. In similar triangles, ratio of corresponding sides is equal. Is it fine?
So similar meaning you're saying that the angle and length is the same or
No,
only
no.
angles are different?
Similarity, if we have done in IGCSE, na, ki if there are two, three rules, if all the three angles of triangles are same, their sides
Yes,
may
sir.
be different, but then we call those triangles as similar.
Okay.
Similar
Yes,
means they differ in ratio. Let's say ki you get your photo clicked, right? You get it
yes,
passport size or you get it uh, like postcard size. What will happen? You will look similar in both the photographs.
yes, sir.
Why you will look similar? Because by the same factor, they are increasing the length and breadth. So that is what similarity is.
So basically, angle is the same and lengths may be different.
Lengths are different.
Lengths are different.
Uh,
Okay.
so there is property that their corresponding sides have same ratio, right? Now, theta is equal. Now, if I consider this arc length AB and this straight side AB, can we consider it as nearly same? Side AB is nearly equal to the arc AB. Can we say? Because curve is very
Arc.
small.
Um.
This curve,
So,
if I
but isn't
consider,
that curve though?
this
Isn't
is
that a
curve,
curve
but
though?
curve will also have some length.
Yes, sir.
So if I measure the length of this curve AB or if I measure this straight line AB, are they near the same? Can we consider,
Yes, sir. Yeah, it
right?
comes.
So theta is length of arc by radius, but since they are nearly same, can we write it as AB upon R? Can we write this delta theta equal AB upon R?
AB upon R. Yeah.
Right?
Yes.
Now in this triangle, if I have to, if del and if these two triangles are similar, then corresponding sides will be equal. Means AB upon R is equal delta V upon. Now, if let's say ki magnitude of VA equals magnitude of VB equals V, right? Means both sides have magnitude V. Can we write delta AB by R is equal delta V by V? Corresponding sides we are taking. And corresponding side we
So
are
we're
taking
taking
this
B
side,
and B as same.
uh, this side by this side of this triangle, this side and this side of this second triangle. Both will have same ratio,
Yeah, yeah. Yes.
right? So, and but we know that AB by R is equal to delta theta. So can we write that delta theta is equal to delta V by V? Fine. Delta theta equal delta V by V.
Yeah. Yeah, yeah,
No-
yeah, yeah.
Right. Now we will divide both sides by delta T. Right. Dividing both sides by delta T. Now, if you will divide both sides by delta T, what you will get? We will get that delta theta divided by delta T is equal delta V divided by V and then delta T. Right. Now, what is delta theta by delta T?
Um, Velocity,
Which
angular,
velocity? This is angular
angular
velocity,
velocity.
right? And
Yeah,
angular velocity we denote by omega, right?
yeah, omega.
And what is delta V by delta T?
Um,
Delta V by delta T. What is delta V?
Delta V.
Change in
Delta
linear
V.
velocity.
Yeah, distance.
What is
Yes, yeah,
delta
yes.
T? Time taken. Change in velocity by time taken is acceleration.
Yeah. Acceleration.
So
Yeah.
we will
Acceleration.
have relation omega is equal to A upon V, or we will have relation A is equal to V omega, right? Further, we have derived relation that V is equal omega R. If you remember, we have derived this relation, linear speed and angular
Yes,
speed
sir.
relation. So if we substitute
Yeah.
this value here, so we will get A is equal omega R into omega. We will get A is equal omega square R. Fine. So this is one expression for the centripetal force. And if we substitute omega is equal to V upon R in this equation, then we will have A is equal V into V upon R. We will have A is equal V square divided by R. V square divided by R. So these are the two relations for centripetal acceleration. Is it fine?
Sir, the second one I understand. What did you do? A is equal to.
See, we have this relation A is equal to V times omega, and V is equal to omega R we have. Can we write omega as V upon R? If you substitute here, so what you will get? A is equal V times V upon R. If A equal V times V upon R, we will get A is equal V square upon R,
Yes.
right? So three relations we have. A is equal V omega, A is equal V square upon R, or A is equal to omega square R. So these are the three relations for the centripetal acceleration. So we can represent it by AC also, centripetal acceleration. Fine.
Yes, sir.
Now, if this is centripetal acceleration, what does Newton's second law of motion states? There is one equation from Newton's second law of motion that relates force and mass. How force and acceleration are related?
F is equal to ma.
F is equal to ma. So centripetal force will be mass times centripetal acceleration. So centripetal force is equal m omega square r, or centripetal force is equal mv square by, fine. So from this expression, you can see that centripetal force is directly proportional to mass, directly proportional to velocity by square, but inversely proportional to r. Means more the radius, less will be the centripetal force. More the mass and velocity, more will be the centripetal force. Is it fine?
Yes, sir.
We will solve one question. Right? Example, I'll consider one. There is a
Sir, can
tried.
we write this also? Like for the force centripetal, can we write V W, not W, angular speed. V into angular speed, though.
V times angular speed you can write.
Yeah, okay.
So we'll consider example ki a toy truck having mass 0.40 kg travels around a horizontal track of radius 0.5 meter. So track of the radius is 0.50 meter, and it makes three revolutions every 10 seconds. Three revolutions every 10 seconds. So this data is given, right? So first part that we have to solve is calculate its speed. We have to calculate its speed, right? How can we calculate speed? We have done that speed V is equal to omega times R, right? And
Yes,
omega, if you remember, we have done omega is 2 pi upon time period. Can we write V is equal to 2 pi upon time period into R?
yes,
And what is time period? Time taken
10
to
seconds.
complete one revolution.
Yeah,
Three revolutions in 10 seconds. So one revolution will be completed in 10 by 3 seconds.
yes,
So we will substitute values here. So we will get V is equal 2 pi divided by 10 by 3 and multiply by radius. Radius is given 0.50, right? So you can do this calculation to find the velocity v. If you will do this, so you will get, I can do it on calculator. Uh, just
Yes, I got 0.942.
okay, you got 0
942
units
units meters
meter
per
per
second.
second.
Yes.
And second part we have to solve is calculate its centripetal acceleration. Centripetal acceleration we have to find. And centripetal acceleration, we have done that force is equal to mv square by r. Mass is given 0.40 kg multiplied by velocity. Velocity, I will suggest if you have taken rounded off value here. So here when you are calculating, you take original value, or you can take this 0.942 square divided by r. R is 0.50. You will get value of centripetal acceleration here. Centripetal force, sorry. Oh, sorry. Here I have calculated centripetal force, right? And when you have to calculate
Yes.
centripetal acceleration, so what you can do is, we know that centripetal acceleration will be centripetal force divided by mass, right? So whatever answer you are getting here, divide it by mass, you will get your centripetal acceleration, right?
Yes, sir.